Hello everyone. So in the last lectures, I talked about up to sedimentation process, which was a plain sedimentation process. Today we will be discussing about the sedimentation with coagulation. What is it all about? So first and foremost thing that comes into mind is what is coagulation all about? Okay. So sedimentation with coagulation involves the process in which the particles which are finer or which are smaller in size, they don't get settled too easily. Sedimentation is a quite quick process, or you can say it is faster in speed. So in that way, the finer particles take a lot of time to settle down in the sedimentation tank. So in that case, plain sedimentation is not recommended. So yes, they may pass on to the filtration process also if we don't treat the suspended particles or the finer particles that don't settle down too easily. They may get onto the filtration process as well. So they are to be removed only if they are uh, clumped together, or we can say they are coagulated together to form larger particles. For that matter, mm, we need to join them together. But the thing is, they are negatively charged, or we can say they don't attract each other, they repel each other. Okay, so in that way, we go with sedimentation with coagulation, wherein we increase the size of particles to let them settle down. Okay, so the energy that we need to do such thing, the energy that we need to conduct this process is known as threshold energy, which is provided to induce the rapid mixing of water. Due to the rapid mixing, these small particles will join together, they will form large particles, and they will settle down at the bottom and can be removed easily. After this, we have if you talk of sedimentation with coagulation process involves three things. Three things are important in it, which is fast mixing, slow mixing, and lastly, sedimentation. This is what happens in the process of coagulation. Fast mixing, as I already told you, is a rapid mixing wherein the larger particles come together, form large blocks, and then they are removed. But here, what we do is we go with the rapid mixing kind of a thing. We add the chemicals to it, chemical to the water, wherein these chemicals neutralize the charge of the impurity, or we can say suspended particles, and then they are removed. Okay, so here we need the rapid mixing. Slow mixing is flocculation. Okay, and then sedimentation. Okay, what are the coagulants used in such processes? They are firstly it's alum, then we have copperas, then we have lime, and plus we have sodium aluminate, and we have chlorinated copperas. Okay, so these are some of the coagulants that may be used in the process of coagulation, aided sedimentation. Okay, moving on. Acha, if you talk of this alum is one of the coagulants that is used, and alum is widely used as a coagulant. I'll tell you why, because it is cheaper in price, it's easily available, be it in liquid form or solid form. It is available, easily available. It is very fast. It works in wider range of pH. So yes, alum is widely used. It's faster. It accelerates the process of coagulation. So it is most widely used. So if we go with this process wherein we add alum to the alum as a coagulant uh, to water, in that case what happens is this process induces hardness to water. okay, which is due to the presence of calcium carbonate, and it increases the acidity of water, which is due to the presence of carbon dioxide. These are the byproducts that we get out of the chemical reaction between the alum and the impurities that may be present in water. Now, here, if alkalinity is not present, in that case, what we do is we add the external alkaline agents like lime, or we can say soda ash, to add the alkalinity to the water, which means we are inducing the artificial alkalinity. For that, we are using soda ash or we are using lime. So, for example, if we are using lime, you are adding lime to it, in that case, acidity is not induced, hardness is induced. Okay, here in this case, acidity is not induced, hardness is induced. So, but when you are using soda ash, when soda ash is added, in that case, vice versa happens, wherein acidity is induced, but hardness is not induced. So the dosage that we use for alum is 10 to 30 milligram per liter. Okay. Similarly, if you come talk about the copperas, which is which also adds to the hardness of water, which is also used as a coagulant. So yes, it adds to the hardness of water, and it is not used for treatment of colored water because it forms that carcinogenic compounds. That is why it is not used for colored water. Okay. Then coming to this chlorinated copperas, this is it forms the whenever we go with this process, what do we get is the chlorination of copper as, which I already discussed about copper as, which is, you know, which is not used for the treatment of colored water, or which adds to the hardness of water. When we go for the chlorination of copper as, it gives us the chlorinated copper as, which is used as alum, which is used as this coagulant. Okay, not for colored water, any other water. We can use it as coagulant. Okay. Now the dosage of copper is same as alum, which is 10 to 30 milligram per liter. Okay. Coming to sodium aluminate removes this. When we add sodium aluminate to water, this process removes both temporary and permanent hardness. It removes hardness. It doesn't induce hardness. Okay. So what happens is this sodium aluminate reacts with calcium and magnesium, which may be present in the impure water that you're working on, that you're treating. So yes, it reacts with the calcium and magnesium to form that sticky precipitate of calcium and magnesium aluminate. So yes, this is how it removes the temporary or permanent hardness of water. So here the presence of alkalinity is not required. Like in case of alum, we induce the artificial alkalinity. In this case, alkalinity is not required in case of sodium aluminate. Okay. So these are some of the coagulants that are used for this process. Okay, moving on. Then we have coagulation methods. What are the methods we use for coagulation processes? In that case, we have first one is horizontal flow basin. As you can see, this shows the horizontal flow. In coagulation, as I told you, it's a rapid mixing. So if you talk of coagulation methods, it depends on the uh, you know method of mixing that you're adopting. Here, as you can see, is it's a horizontal flow basin, right? Here the flow is being the water is being flown in a horizontal manner, and this is the top view of the basin. Okay. So in this kind of mixing, what do we do is the mixing is done by the turbulence of water. How does this turbulence occur, or we can say how does this disturbance in water occur? What do we do is we continuously change the direction of the flow of water. By changing the direction, there will be the turbulence of water. When there is continuous turbulence, there will be mixing of water. What are we mixing it with? It is the chemicals. Coagulation is the reaction between the chemical coagulant, whatever coagulant you're using, chemical reaction between the coagulant and water, coagulant and the impurities that are present in water. So for that sense, For that matter, we need to mix the water properly. Okay, so this is how it is. Coming to the second method, it is the vertical one, which is vertical flow basin. And this is the front view of the vertical basin. Again, here mixing is done by uh, creating the turbulence, which is done by the continuous change in the direction of flow. Here, the flow is water is flowing in the vertical direction. Vertically, it's flowing vertically. There, what were we doing is the water was flowing horizontally. Okay, moving on. Okay, so this was the thing that I was discussing was horizontal and vertical flow. It was something that we were inducing. That it was something that we were just changing the directions, but the water was flowing naturally. We were not uh, generating some power. We were not providing some power to it. It was flowing. Okay, but in this case, if you go with the mechanical mixers, wherein these, as you can see, this is the view of the mixer, wherein these paddles keep on moving. They keep on moving, they keep on rotating. So, due to which again turbulence is induced in water. But here, the turbulence is induced mechanically. We're making use of mixers. Okay, so these paddles keep on moving, due to which the turbulence is created, due to which the particles mix up with the chemical, mix up with the coagulant, and with the help of coagulants, those particles, form larger particles, and then they are removed. Okay, so this is how it is. After this, we have flocculation. So what is this flocculation all about? Now, see, coagulation, what you did was you neutralized the charge of particles. Particles, impurities are usually negatively charged. So you need they will repel each other. So you need to neutralize them. When you come to the flocculation process, it involves the removal of very fine particles which do not get removed in the coagulation as well. Okay, so in this case, what we do is in the process of flocculation, when these fine particles enter the flocculation tank, wherein these particles are neutral in charge. Okay, we don't need to do anything. They are neutral in charge because we added coagulants and they are neutral in charge right now. So, these suspended particles are neutral in charge, and then what happens is a flocculation is a process, is a slow mixing process. Here, the mixing is done very slowly. So these particles are being mixed, or we can say they bond together to form the flocks, to form the large fragments, or we can say to form the large particles called flocks. So with the slow mixing, these particles come together, they attract each other, they form the large particles called flocks, and then they are removed. If we go for the rapid mixing in flocculation as well, what will happen is these large particles that are formed due to flocculation uh, will divide into smaller particles, finer particles, which will further be difficult, will be further very difficult to be removed. So yes, it is like we need to go for slow mixing and flocculation process. These are finally removed in the sedimentation process. We go with the coagulation, then flocculation, and then they are settled down in the sedimentation tank and then removed off. So in sedimentation tank, you will get the clear water over there. Okay, this is something which happens in flocculation. So as you can see, these are all negatively charged, and these coagulants that we use, they act as a bridge of positive charge, and they neutralize with it. See, they are attracting with each other in this process and forming a bridge, thereby forming a large fragment. As you can see, these are negatively charged particles, and they neutralize, forming a bridge, and then Positively charged particles, coagulants act as positively charged particles, or positively charged chemicals, or you can say. So yeah, they form a bridge, and hence a large fragment, a large particle is formed. This is flocculation process. So see here so the water that enters the flocculation tank. What happens is here, as you can see here, the water is entering the flocculation tank. So these paddles, with the help of these paddles, the paddle is moving at a very slower rate, and water is flowing into the paddle. So the small particles, or we can say the neutrally charged particles, are being combined over here. Okay, so this is how it is. It keeps on rotating, and from here it is being discharged off. Okay, here the clear water is discharged to the sedimentation tank, and from here these charged particles, or we can say the flocks, are being removed from here. Okay, and plus if you're using alum as a coagulant, there will be less production of sludge. Okay, so this was something I needed to tell you. So yeah, if you're using alum as a coagulant, there will be less sludge formation. Okay, moving on. Then after flocculation and sedimentation and coagulation, everything is being done. Suspended particles are being removed from it. Now coming to the filtration part. Now very fine particles, or we can say some of the flocks that may have escaped the flocculation tank, colloidal impurities, they may escape the sedimentation tank, they may escape the flocculation and coagulation process. What will happen to these particles? They will come to the filtration tank, enter the filtration process. So filtration process is meant for this only, wherein we remove the rest of the impurities, and they are being removed to the maximum. So this is the limiting step where the microorganisms, the organic matter, the suspended impurities, colloidal impurities, any flocks that may be present over there, they are removed by the process of flocculation. And microorganisms are removed to a very larger extent. And uh, if few of microorganisms, few amount of microorganisms are still present in water, then they can be removed by disinfection process. But in filtration, it is the limiting step. Okay, herein we remove each and every, we try and remove each and every impurity. Okay, so what next? Then we have theory of filtration. Okay, moving on to the theory of filtration. What do we do is, in filtration we have whenever water is filtered through filter media, what happens is um, lot of actions take place. Whenever water enters the filtration tank, there we have the filter media, which acts as the medium through which the clear water can be achieved. So in this process, what happens is lot of actions take place, lot of things go on in this process, wherein we have this what do we call as mechanical straining, and then we have one more process, and that is sedimentation, and then we have one more process, that is biological action, and then we have one more process, and that is electrolytic action. So these are certain things that enact in this process. So talking about the mechanical straining, what is this mechanical straining all about? As you can see in the picture, these see the filter material, as we can talk about filter material. This material consists of three layers. Filter media consists of three layers, which is fine sand, then we have coarse sand, then we have gravel. Okay, so yeah, these suspended particles, when you talk of, when they are bigger in size, or when they are larger than the voids that are present in the sand layer, as sand is perforated, or we can say it is porous in nature. In that case, the layer of sand, the layer of bed of sand that we have over there in the filter media, it may get clogged. It may get clogged due to the particles which are larger in size, which are coarser. Okay, so the particles which are larger or coarser than the voids, they will get arrested over there and they will settle down over there. Okay, so yes, in mechanical straining, these arrested particles they form a film or they form a layer over the top of the sand layer. Okay, they form a mat over the sand layer, due to which it helps in the further removal of the impurities from water. Okay, because the particles which will be much finer than this mat, they will be retained over that mat. Okay, so in that way, it can help in the further cleansing of water. All right, so this is the mechanical straining. As you can see over here also, this is the deposition of the coarser particles over the voids, that is between the grains of sand. Okay, so this was mechanical straining. After that, we have biological action. So what happens is, um, the or decomposed organic matter that we have that can be present in water, it may get deposited over the sand, over the layer of sand, or over the sand particles. So whenever it gets deposited, it forms a layer, and that layer is known as dirty skin, or we can say that film is known as dirty film, dirty skin. Okay, so this organic matter, along with iron, manganese, aluminium, silica, it forms a film, a thick film, which is known as dirty skin. Okay, and it acts as extremely straining matter, wherein the fine particles may get deposited. It forms a very what do we say, mist film, wherein we can a mist mat wherein the further deposition can take place, and it helps in the decomposition of organic matter, if at all any organic matter is present in water. So this is very helpful. After this, we have electrolytic action. Now, see, whenever we talk of a filter media, it has certain charge, okay, and the fine particles or the impurities that are coming in contact with that filter media, it also has charge. So, in that sense, what happens is they have opposite charges, right? Filter media has some charge, and talking about the impurities, they have some charge. They are oppositely charged. They will attract each other. So here what will happen is neutralization of charge will take place in water. So yes, uh, this is how, or this is what happens in electrolytic action, wherein the charge of particles will neutralize and hence they will get uh, settled, they will settle down on the layer of sand or filter media, and then pure water can be obtained. Okay, so in this process what happens is, due to the continuous use of this filter medium, or we can say continuous use of filter sand, the charge of sand will get exhausted. In that way, what we will do is we will renew it. How do we renew it? We wash that filter media. There's a process called backwashing, ion exchange process. In this process, what we do is we clear the filter media, due to which we can retain, sorry, due to which we can renew the charge. Okay, okay. The next thing that we have is sedimentation. Now, what happens in sedimentation? It's one of the actions that take place during the process of filtration. That whenever we go for the process of filtration, so what do we do is, I talked about turbulence in coagulation. There is turbulence in filtration due to the mixing. We need turbulence in sedimentation process, but in filtration process we don't need any turbulence. We need water at rest. So whenever we remove the turbulence from water during this process, the suspended particles will tend to settle down. Okay, so the suspended particles will settle over the sand particles because there is no turbulence. The water is at rest. they will get time to settle down. As I already told you, fine particles don't settle down that easily because they don't get time and there is a certain turbulence in water. So yes, they will settle down. So how what will happen is the grains, that means the spaces between the grains of sand, will act as sedimentation tanks for them, small sedimentation tanks. Okay, so they will settle down over there. Moreover, the colloidal impurities that may be present, they will also settle down in those voids, and thereby they will attract more and more suspended impurities to, uh, get settled over there. They will attract more and more impurities, and hence they will settle down in those voids, and they can be removed. And this is what happens in sedimentation. Okay. After this, we have filter material. Okay, now this talking about this filter material, I told you this the filter media consists of gravel, a bed of gravel, a bed of sand. Okay, so the material that is used is sand and gravel. This is it that we can use. Okay, talking about sand, the sand either coarse or fine, it is used. Okay, being the coarser being at the being the first layer and the finer being the top layer. Okay, firstly we go with the coarser and then we go with the finer. So the top layer should be the finer one. So yes, sand can either be finer, it can be either be coarser. It is used. Okay. So the specifications that we use for sand that we have to go for it are firstly is the uh, dirt. Sand should be free from dirt, it should be free from impurities. Okay, and then it should be uniform in size. Each and every grain should be uniform in size. Then it should be hard enough because see, whenever water is flown into the filter media, water is flown into the filter media, it may get disturbed due to the pressure head, due to any disturbance. So yes, it has to be hard. It has to be strong enough. Then we have then we need to test it. For example, if you place this sand in hydrochloric acid for 24 hours, it should not lose its weight. If it's losing its weight, it should not be more than 5% of its weight. So we have to look into it. Okay. Then talking about the size of sand, it should be 0.2 to 0.3 in slow sand filters and 0.35 to 0.6 in rapid sand filters, which I'll be talking about these two, both the types of filters in the future lectures. Talking about gravel, if you talk about gravel, the sand layer, the layer of sand that we have in filter media, it is supported by the gravel bed. Okay, so gravel bed is obviously these are coarse particles that we have. So the gravel that we use for this purpose should be hard. It should be free from impurity. It should be clean. It should be durable. It should be properly rounded. The density of this should be 1600 kg per meter cube. And yes, the gravel is placed in 5 to 6 layers. Okay, and the finest size of gravel is kept on the top. Fine. So yeah, 5 to 6 layers and finer being on the top. The next thing that we need to do is, if you don't have gravel, in place of gravel, what you can use is you can use anthracite, you can use garnet, you can use make use of sand, okay, or any local material like coconut husk can be used, rice husk can be used. So yes, these are some of the materials which can be used in place of gravel if gravel is not available to you. Then we have classification of types of filters, wherein we have pressure filters and gravity filters. In gravity filters, what happens is with water has some head velocity with which it falls into the filtration tank, or we can say filter media. So here, if we talk of gravity filter, it flows under the action of gravity and the velocity head, or the head of water with which it flows into the filtration tank. It depends on the height of water, the height at which the water is the height at which the water is flowing into the tank. Okay. Then, if you talk of pressure filters, in this case, what we do is we always the head of water is required. The velocity with which the water will flow is required. Okay, so for the in this matter, in case of pressure filters, we need to apply pressure over water in order to attain the head with which water will fall into the filtration tank. So here external pressure is exerted on water with which it flows into the tank. This is the pressure. This is the difference between pressure filters and gravity filters. Now gravity filters are further divided into slow sand filters and rapid sand filters. Today we will be discussing about the slow sand filters. So talking about slow sand filter, this is the earliest type of filter. We don't use it anymore because see, in slow sand filter, the rate of filtration is very slow. The process is slow. If the process is slow, the area that we need for this process has to be very much large. Okay, so if the area is large, we need a lot of labor for doing the washing of this filter, because we go for the scrapping process of cleaning, so it needs a lot of labor, so it increases the cost. There is an increased cost of installation, there is cost of labor, so it's not economical and it takes a lot of time, so it is not in use right now. It was used earlier. Okay, so yes, and the rate of filtration in this process is less, as I already told you, is 1/20th of the rate of filtration to the rapid sand filters. Okay, so it is not recommended nowadays. Talking about the components in slow sand filter, we have enclosure tank, we have filter media, which is this. This is the enclosure tank. Then we have the base material. Then we have the under drainage system that we have over here. Okay. Then we have other appurtenances that may be used in this tank, which are usually the measuring devices. Okay. So, and we have the inlet outlet arrangement. The inlet outlet wherein the water flows into the tank, and this is the outlet. Okay. Then we have this enclosure tanks. These enclosure tanks are made up of concrete, or they may be made up of masonry. Okay, and the slope of the bed may be 1 in 100, or it may be 1 in 200, and it is towards the drainage wherein the water will be drained off. Okay, then the depth of tank, it varies from 2.5 to 4 meter. Okay, and the area of this tank, or we can say the plan area wherein this tank whole filtration tank will be planted, it requires only 100 to 200 square meter, and which depends on the quantity of water to be treated. Okay, then we have filter media. Okay, in this what we have is filter media, as I already told you, it consists of sand layer, it consists of gravel layer. The sand layer is supported on the gravel layer. Similar is the case with slow sand filter, but here the sand layers are 90 to 100 centimeters in depth, and the effective size may vary from zero point 0.2 to 0.35, and the uniformity, which is the size of particles and the way it is being distributed over the filter media, it varies from 2 to 3. Okay, so moving on, then we have base material, which is gravel. Okay, base material is gravel because sand is supported by the gravel bed. Okay, so this base material consists of 30 to 75 centimeter thick gravel. Okay, now this gravel can be of different size, as I already told you, the finer one being on the top. Okay, so it varies from layer to layer. Okay, it is from I told you the number of layers for gravel is 5 to 6, but in slow sand filter it is from 3 to 4 layers, and the depth may vary from 50 to 15 to 20 centimeters. Okay, the depth of the each layer may vary from 15 to 20 centimeters. Then there is under drainage system wherein the water is being drained out of the filter media. So the water drainage system consists of a central drain where all the effluent we collect all water from the connecting drains. Okay, so yes, we have collecting drains, or we can say we have lateral drains over there. We have central drains. Okay, so yes, these lateral drains. What are these lateral drains? These are perforated drains, or we can say these are open jointed pipe drains. Wherein perforated are where we have openings. Okay, in the pipe. So yes, we have lateral drains which are connected to central drains. So these lateral drains collect water from the filtration tank, and it is being uh, transported to the central drains. Okay, so this is how it is. And the distance between two drains is 2 to 4 centimeters. So the center to center distance between two lateral drains is 2 to 4 centimeters. Then we have inlet and outlet arrangement. Inlet and outlet uh, it is very obvious that inlet is used for collecting the effluent. The effluent enters the tank from inlet, and inlet should be designed in such a way that that the water flow does not affect or does not disturb the filter media. So it has to be designed in such a way. Outlet, from outlet, what we do is the water is being uh, discharged off to the drains, or we can say discharged off to to the storage tanks, wherein it will be distributed further to the society. So yes, inlet and outlet arrangement is this. Then we have other appurtenances that may be present in the slow sand filters. The first one, these are installed for various purposes. We need some devices to be installed in the slow sand filters or in any process. For this matter, see, whenever water enters the filtration tank, it has some velocity, and whenever it reaches the filter media and passes through it, it has some velocity. There must be some loss in velocity. Okay, there must be some difference between the velocity when it entered the filtration tank and when it passed through the filter media. So there is the loss of head which we need to calculate, which we need to know what was the velocity, what is the velocity. So yes, there must be a device which measures the head loss. Then we need to control the depth of water which is above the filter media, and we need to calculate the depth. What is the depth of water above the filter media? Because more water means more tension of the filter media, and more tension means more disturbance, which may cause rupture of filter media, or we can say which may cause failure of filtration. And after this, then we have rate of flow. Okay, we have to maintain the constant rate of flow. We have to maintain the constant rate of flow in order to maintain the proper working of. So this is it for today. We discussed about the sedimentation with coagulation. We discussed about sedimentation with flocculation, and then we talked about the filtration processes, wherein I told you about the theory of filtration and the actions that take place in during the filtration process, and then we talked about the classification of filters, wherein we have gravity filters, we have pressure filters, and these gravity filters are further divided into slow sand filters and rapid sand filters. And today I talked about the rapid sand filters. In the further future lecture, I will be, or in the next lecture, I will be discussing about the rapid sand filters and the design of both slow and rapid sand filter, and the cleaning of filters, wherein we have backwashing, we have ion exchange processes. So yeah, I'll be discussing all these things in the next lecture, next coming lecture. For today, that's all. Um, and let's meet next time. Thank you. Have a good one. Bye bye.